Have you ever wondered how to efficiently share tabular data with colleagues, other teams, or external partners? Stay tuned for a deep dive into the wide variety of options available in Google Cloud and prepare to be amazed at how they can revolutionize your approach to data sharing. Specifically, we're going to zero in on the details of sharing tabular data from BigQuery. Ready to dive in? Let's kick things off by setting up a simple data set for our BigQuery adventure. We're not just pulling fake synthetic data here, we're utilizing real, public data sets available right in BigQuery. The perfect specimen for our exploration, some good old US Census data. To get our hands on this treasure, it's time for us to channel our inner copycat. Cue a dataset copy operation in Google Cloud. We specify the census dataset and set in motion a data transfer, duplicating the dataset right into our playground. We only need to run this sync once for the demonstration, so we'll select an on-demand schedule. Voila! With the specification submitted, we can run the transfer. While we wait for that dataset copy, let's highlight the different paths for data sharing that we're going to blaze through in this video. Our journey begins with the BigQuery dataset, but leads us to uncharted territory like Analytics Hub, a Google Cloud service tailored specifically for external data sharing and bustling data exchanges. But wait, there's more. We'll explore how standard identity and access management can become your closest allies in the quest to share datasets. This involves maneuvering through crucial controls like column level security, row level security, and authorized views. Our data sharing excursion doesn't stop there. We're also venturing into the realm of Dataplex, where we'll see important data sharing concepts like cataloging, discovery, and scalable access management. Furthermore, we're going to shed light on cloud storage for simple exports like good old CSV files, perfect for those who need a simple turnkey approach. To keep things even more interesting, we'll also consider APIs, like those built with Cloud Functions, giving us new levels of control over our data sharing. Wrapping up our in-depth exploration, we'll touch on business intelligence solutions like Looker from Google Cloud. We'll evaluate each of these options, stacking up initial setup effort, data freshness, technical complexity, externalization capabilities, and the ease of data use after sharing. We'll record our observations on a matrix so that by the end of this video, you'll have a clear and succinct reflection of the data sharing similarities and differences. We explore these varied options not just to pick an approach, but so that you can mix and match for your particular scenario. These options are not mutually exclusive. Jumping back into the console, let's not forget about our US Census data waiting patiently in our SQL workspace. Including both standard and partitionized tables, it's a tantalizing mix of various asset types. Curious about our first data sharing option? Let's dig deeper, beginning with an export to Google Cloud Storage in the lingua franca of data, the CSV file. A quick bucket creation later, and presto, we have a pathway to sharing data with the world. But hold on to your hats. It's not all sunshine and rainbows. This approach is simple to kickstart, but we're essentially packaging up a time-capsuled snapshot of the dataset, not sharing the live data itself. Though the technical bar is low and the externalization high, controls and security fall short. The ease by which CSVs can be email forwarded, copied across storage mediums, and shared across individuals with minimal access control means that the data falls largely outside of your control upon initial export. That all said, data usability is king, thanks to the CSV file being a very common import or integration format in data analytics tools. Continue with us as we unravel more data sharing paths, taking us back to BigQuery for the next chapter of our adventure. Our next option utilizes simple IAM and security controls for securely sharing our data. This usually entails a combination of access controls. For example, when we navigate to Edit Schema, there's a Policy Tags option, which allows us to manage column-level access. Heading into the Policy Tags section of Google Cloud and enabling the Data Catalog API, we can set column-level security for a more secure data sharing among individuals within our Google Cloud environment. From here, we create a taxonomy. Let's name it sensitive. And within that taxonomy, we set up a PII policy tag. Enabling an API is necessary to view data policies, and once done, we apply this policy to our dataset. Imagine that two fields in this table contain sensitive, personally identifiable information. We would attach the PII policy tag to them. These policy tag permissions are in addition to the dataset permissions, hence a user needs access to this census dataset as well as explicit permission to the sensitive PII column. Similar to the column level access controls, we have row level access controls, which are managed through SQL commands. We could, for instance, formulate a row access policy on a table which allows a specific user to view only certain rows. This policy benefits from the flexibility of being applicable not just to individuals, but also to entire groups or domains. To allow access to dataset views without providing access to the underlying data, we leverage authorized views. When sharing these views through standard IAM permission structures, access to underlying tables isn't necessary. These are just a few possibilities to securely share data using IAM and standard BigQuery security features, and these data asset level controls are fully complemented by the IAM policies at the dataset and project levels. Custom roles can satisfy more stringent and custom requirements in this area. Examining this IAM and security approach, we find the initial setup relatively low effort since we utilize the built-in security mechanisms. The data freshness remains excellent as we are sharing the data directly. The technical barrier is moderate due to the careful management of permissions, particularly when external partners are involved. Externalizability isn't ideal as individuals need access to Google Cloud and your project. The data usability is moderate, as accessibility isn't trivial, although the native format of the data usually eases analytics and BI usage. Moving on, let's discuss Analytics Hub. After enabling the API, an exchange is created, functioning as a sort of bucket for sharing multiple data listings. Filling out as many metadata fields as possible enhances the utility of the Analytics Hub approach as it provides a richer cataloging and usage experience. Our next step involves adding entities to manage, publish, subscribe, and view the listings in the exchange. We'll proceed with the defaults, a fully private initial configuration for this exchange. After clicking into the new exchange, we can create listings for our data assets. We have extensive control over data egress, allowing us to mandate that subscribers cannot copy or export shared data or query results. Once we have provided sufficient metadata and documentation for the listing, we can save and proceed to review the listing. Presented with all the metadata in a comprehensive layout, this essentially serves as a landing page for our data. Currently, we have no listing subscribers. Adding the dataset to our project allows us to include ourselves as subscribers, viewable under Subscription Management. While we're acting as both the data producer and data subscriber for the sake of the demonstration, these are usually separate parties and different organizations. Permissions are crucial at both the exchange and listing levels. To make the listing public, we simply need to enable all users as Analytics Hub subscribers, thus allowing them to browse the exchange, subscribe to listings, and use the data. As more subscriptions and job executions are incurred against the shared data, a visualization of usage metrics becomes available. A search experience facilitates the discovery of public and private datasets for a richer user experience. Turning our focus to the Analytics Hub results, we observe that initial setup work is moderate, data freshness is excellent, and the technical barrier is low to moderate. The externalizability is superb, as we can share with other organizations, monitor usage, and prevent unwanted data exfiltration or copying. Ease of data usage is also high since subscribers receive the data in its native format for utilization in their BigQuery environment. Moving forward, let's investigate the API path. Within the console, we'll construct our API over our census data by utilizing cloud functions. We'll customize the cloud function by upgrading the memory capacity and specifying a service account which has permissions over our BigQuery data. Considering the row-level policies applied to our counties table, we'll switch to a different data asset, adjacent counties, for this API demonstration. Awareness of API restrictions is important. For instance, they should not dump large volumes of data, but rather filter, target, and paginate the data needed by our API consumers. Regardless, to showcase the concept, we'll proceed to deploy this function as is. Once the function is deployed, we'll use the public endpoint to access our data. Of course, you'll probably want to think through security, performance, documentation, metering, and possibly monetization here. A proper API platform like Google Cloud's Apigee can help in these areas. For the API option, the initial work is relatively high as it involves setting up and securing APIs. While the initial data freshness is good, generated by live data pulls, if client applications process this data, it can become disconnected from its original source. Clients may need to regularly repull data to try and maximize the data freshness. The technical barrier is high as the APIs require application development and cloud engineering work. However, the externalization is exceptional given that externally facing REST APIs are ubiquitous. The ease of use is moderate, as data consumers still need to integrate the output of these APIs into their scripts or data platforms. Let's consider a couple of additional options. Dataplex, a data fabric service in Google Cloud, provides tools like data cataloging and structured permission management. This system provides an abstraction level for data, enabling us to search for assets like BigQuery tables. Using logical groupings of analytics and intelligence assets, like with data lakes and data zones, it ensures efficient policy propagation for secure and easy sharing. Dataplex requires moderate initial work due to its conceptual complexity, despite being no-code and less technically challenging. It offers excellent data freshness and low technical barriers, but poor externalizability. The service is typically just an internal to the organization's system for cataloging data and managing access. Its ease of use is perhaps moderate. Lastly, we can think about classic business intelligence solutions. Looker Studio, provided free as a part of the Google Cloud system, allows us to explore data and build charts with familiar metric and dimension constructs. For instance, we might examine land area and water area in our census data. The critical aspect here is the capability to share data indirectly as charts and visualizations through the system. Transitioning to the full-blown Looker service, we can enjoy a high-quality, enterprise-grade business intelligence experience. However, this higher tier of solution naturally comes with a higher price tag. Initial setup work for this platform is comparatively high as it requires us to establish a new system and manually construct insightful dashboards. However, the data freshness is excellent as Looker works directly with data warehouses. With a moderate to high technical barrier, building out explorable data experiences in Looker might be challenging. In terms of externalization, it scores high due to the controlled access it offers to specific dashboards. Its ease of use is somewhat high, although the lack of low-level data access and control can somewhat stifle usage by external parties. Examining the full tabulated results, file exports could be a viable option if you're seeking a quick and easy solution. However, if data freshness is crucial, your ideal options would be standard IAM and Security, Analytics Hub, Dataplex, or Business Intelligence solutions, all of which are built around the live data warehouse datasets. Among the options, flat file exports and Analytics Hub present the lowest technical barriers. When it comes to externalization, Analytics Hub and APIs emerge as exceptional contenders, offering user-friendly experiences for external parties. As for ease of use, Analytics Hub and CSV file exports are standouts. Unsurprisingly, Google Cloud's dedicated service for securely sharing data, Analytics Hub, scores well as it has been purpose-built for this specific use case. However, again, you may want to mix and match some of these options rather than picking the best to effectively cover your use case. We'll be keeping an eye on the comment section for any questions. Thank you for watching, and please enjoy responsibly.